பார்ப்போம். Now we will define the parameter, that is one parameter, that is power saving. So this term power saving is always with respect to the AM system. Why? Because in AM we are using carrier upper sideband and lower sideband. That means we are utilizing more power. When we come to the DSB, we are saving the carrier power. When we come to SSB, we are saving carrier power as well as any one of the sideband power. So this power saving formula is always with respect to the AM system. This is always with respect to AM system, because AM system is the base system with respect to the AM system. That you have to remember properly, because in future you may get confused with this definition and another definition. So that's why I'm telling the power saving is always with respect to the reference technique, that is AM system. So now what is the power saving in DSB scheme? What is the power saving in DSB scheme? That is power saving PS in DSB scheme is equal to, what is the power saved? What is the power saved? What is the reference technique? What is the reference technique? The reference technique is AM technique. What is the power used in the AM? That means as compared to AM power, now directly we can write the AM power, that is AM total power, that is PC multiplied with 1 plus mu square by 2. Here, how much amount of power I am saving? PC amount of power I am saving, because in DSB I am not using PC. That means I am saving that power. Okay, that means how much power you are saving in DSB, that you have to write it in the numerator. So if PC cancels, then directly I can write 2 by 2 plus mu square is the DSBSC power saving. So once if you are given with mu, then directly you can write what is the power saving. And then we know in case of DSB, the maximum mu is 1. Okay, so if mu is equal to 1, because the maximum value of modulation index in DSBSC is 1, then what is the amount of power saving when mu is equal to 1? So that is simply 2 by 3 into 100. Power saving in terms of percentage. Okay, we want to tell sometime in terms of percentage. If it is percentage, then I have to multiply by 100. So the amount of power saving is equal to 66.6% for the DSB system. Next, what is the power saving in the SSB system, single sideband system? Again, power saving formula is equal to what is the power saved with reference to the reference technique, that is AM technique, AM power. So in SSB, we are saving both carrier power as well as one sideband power. Okay, any one of the sideband. We are saving both carrier as well as any one of the sideband. That means I can write like carrier power plus sideband power, that is PC mu square divided by 4, PC 1 plus mu square by 2. So again, I can take PC outside, then finally I will get 1 plus mu square divided by 4, and then 1 plus mu square divided by 2. Again, you can simplify this formula further. Okay, so this is the formula of power saving for SSB system, single sideband system. So next, we'll write the formula for transmitter efficiency. Okay, transmitter efficiency. Transmitter efficiency. So this efficiency is with respect to its own technique. Okay, whenever we see the efficiency, we will compare our performance with ourselves. It's like transmitter efficiency means with respect to the own technique. This is with respect to own technique. So now say if I want to compare or generalize, what is the generalized formula for efficiency? In any system, you will be using some power, total transmitted power. Out of that transmitted power, what is the useful power? Okay, how much power is useful? Total useful power. Okay, so this is the formula for efficiency. You are transmitting some power, but in that, how much percentage of power is actually useful? That is the transmitter efficiency. See, in case of AM, okay, we are transmitting carrier upper sideband, lower sideband. Okay, then actually the useful power is in the sidebands. The useful power is available in the sidebands. So just I will write the only sidebands power, both upper sideband as well as lower sideband. Okay, the power in the sideband is PC mu square by 2. This is the power in the sideband in the AM system, because that is the useful power. But what is the total power we are transmitting? That is PC 1 plus mu square by 2. Okay, then we can cancel PC. Then finally we'll get mu square divided by 2 plus mu square. Mu square divided by 2 plus mu square. Then suppose if mu is equal to 1, what is the transmitter efficiency? That is 33 percentage. 33 percentage. Once if you want to write it in terms of percentage, just multiply by 100. 33 percentage. When mu is equal to 1, transmitter efficiency is 33 percentage. Then what is the efficiency of other system, say DSB and then SSB system? Okay, in DSB system we are transmitting only sidebands. Okay, we are transmitting, so the total transmitted power in DSB is only sidebands power, that is PC mu square by 2. Again, that sideband power is actually the useful power that we will be using at the receiver side for recovery. So useful power is also same. So I am getting 1. That means the efficiency of the DSB system is 100%. Similarly, for SSB system, I am transmitting PC mu square by 4. Again, that power is actually the useful power because we are sending only any one of the sidebands. So PC mu square divided by 4, again 1, again it is 100%. Okay, so always you have to remember this formula. Mostly in the exam, they will ask based on this formula. Very rarely, they will also ask for DSB and SSB also. So this is about the transmitter efficiency. Again, you should not get confused between the term power saving and efficiency. Power saving means always with respect to the AM system. Efficiency means with respect to its own technique, with respect to the own technique. So now I'll just write the comparison for all the 3 technique. Different AM system at mu is equal to 1. Different AM system at mu is equal to 1. Say AM, the another name for AM is double sideband full carrier. Another name for AM is double sideband full carrier. Then double sideband suppressed carrier. Okay. Again, single sideband full carrier. Single sideband full carrier, single sideband suppressed carrier. Okay, so actually we are not discussing this term. Okay, single sideband full carrier is also available. Sometimes we will use single sideband, any one of the sideband with the full carrier. Okay, due to some reason. Okay, so this is the technique we have not discussed, but directly we will write the formula. So what is the total power in all the cases? Again, AM can also be called as double sideband full carrier. That means both the sidebands are there, carrier is also there, then that means that is equivalent to AM. Okay, different name use பண்றதுக்கு chance இருக்கு. So this is PC 1 plus mu square by 2. Okay, then double sideband suppressed carrier is PC mu square divided by 2. Then single sideband full carrier is PC plus PC mu square divided by 4. This is PC mu square divided by 4. Next, power saving. Okay, so write the heading. This is total power. Next, power saving, bandwidth, then power saving efficiency in terms of percentage. Power saving in terms of percentage when mu is equal to 1. So we will not have any power saving in AM. Then what is the power saved in the DSB, that is PC? What is the power saved in the SSB full carrier? That means only one sideband power, that is PC mu square by 4. What is the power saving in SSBSC? Okay, PC as well as any one of the sideband, that is PC plus PC mu square by 4. Then what is the bandwidth of AM? That is 2 FM. For DSB also 2 FM. Single sideband full carrier FM only. For single sideband also only FM only. Power saving percentage. Okay, so for DSB we will get 16.66% when mu is equal to 1. Here we will get 16%. Here we will get 83%. Okay, just calculate it. Then what is the final important things here regarding the complexity? Okay, out of the system, which is really complex? Design point of view. Complexity. Okay, again, this complexity we are writing with respect to the receiver. Whenever we are designing the system, we have to design both transmitter as well as the receiver. Okay. When the receiver, when it is a broadcasting type of system, there will be only one transmitter and many number of receivers. So whenever there are many number of receivers, again, the receiver should not be too complex. If it is too complex, the cost will be high. Again, more number of user will not buy that equipment. So whenever we design a system, okay, if it a single transmitter, again the transmitter cost may be anything, but in case of receiver, we will be using millions of receiver. Again, the end user equipment cost must be as low as possible. So that means complexity I'm writing with respect to the receiver. With respect to receiver, because in broadcasting type of system, will not worry about what is the cost of the transmitter. Mostly we have to worry about with respect to the receiver. So out of all these, we will use AM because AM receiver is simple to design. AM receiver is simple to design. And so as it is simple, it is low cost. But SSB may be having advantage over power and bandwidth, but it is difficult to design. Design is complex. Okay, SSB receiver design is complex. So it will take high cost. This is the main difference you have to understand. So SSB may be having advantage in terms of power and bandwidth, but the design of receiver is really complex. Again, high cost. So mostly we will not use SSB system for broadcasting type of communication. So this is the main reason we will not use SSB. We won't use SSB for broadcast type of communication, for broadcasting communication. But AM we will be using for broadcasting because it is simple to design. So that's why AM receiver will be used for broadcasting communication, broadcast type of communication. Broadcast means one transmitter, many receiver. But then where we can use SSB? When you want to send one-to-one communication, when you want to make one-to-one communication, you can use SSB type of system. Okay, single transmitter and single receiver. Even though the cost is high, only one transmitter, one receiver only. So mostly we will use SSB system for one-to-one communication. Okay, so this is the main difference. Okay, main difference or comparison among these systems, different three types of systems. Next, just we have seen only the mathematical equations, modulation equation and then mathematical equation for power. Then we have defined power saving, and then